Hi and welcome. Today we will be walking through a basic setup of Vagrant and VirtualBox using Chef as a provisioner. The application we're going to start with has none of this configured, so we're starting from scratch. We have a few tags set up in the project in GitHub so that you can skip ahead to different checkpoints if you like. The 020 checkpoint is going to be Vagrant. 030 will be test with a Fabric deployment script. 040 won't cover in video, but we'll be expanding the project to make it production ready. And then 050 will be adding the production environment. Before we get started, let's make sure we're all on the same page. I'm running with Vagrant version 1.8.1. The reason for this is I actually run in 1.7.3 usually, but 1.8.1 is required if we want to use Chef 0 as the provisioner, which we do, because it most closely resembles the client-server relationship that you might experience in some Chef deployments. If you're not on this version, you can still use this demonstration as an example. You may not need to make any changes at all, actually, but you can run Chef solo. You just won't be able to run Chef 0. VirtualBox is at version 4.3.30, and I have the Vagrant VB Guest plugin installed, which we'll see in a little bit, manages the Guest Edition version of our VM. Guest Editions is a set of applications and drivers that run on the virtual machine to help VirtualBox do its job for sharing folders and making things a little bit more performant. So let's create the folders that we'll need to hold our configuration files. The cookbooks folder holds a sample cookbook with 2 recipes, an API recipe and a web recipe. One for the Flask API service in the GitHub project and one for the front-end service. Each application we will focus on independently in this respect. So also in roles, we'll have an API role and a web role. And this is so that we can assign roles independent of the servers to which we are deploying them. We'll have a nodes folder to hold our node configuration, a node representing a server, and an environments folder to hold our environment configuration. So let's get started by populating each of these files with the appropriate config. Our recipes actually look very similar because the 2 parts of our application, the Flask API and the front end, have very similar requirements to run them. We actually share a requirements file at this time. We'll be changing that later. The roles we'll have are an API role and a web role. We have 2 different services, and they are each to be treated independently. So we assign one API recipe to the API role, the web recipe to the web role, and our development environment configuration, which just has a single attribute of base folder. You can think of a Chef attribute as kind of a variable that can have a different value depending on the environment in which it is operating. In our case, base folder will refer to /vagrant because that is where our application code will live inside the VM. Last, let's create our Vagrant file. We can do this with a Vagrant init command, or we could simply just create the file on disk. It will have the same effect. Vagrant init doesn't do anything special other than that. The one nice thing that it does do, though, is it gives us a Vagrant file that is pre-populated with a lot of documentation that explains just what a Vagrant file can do. So you can see, and a lot of it is commented out, but it kind of gives explanations on the different instructions that you can provide to Vagrant to let it do its job. It's a good idea to read through that. It's pretty informative. We're just going to paste our own in to get started. We define our VirtualBox VM as Ubuntu Trusty 64. Without saying anything else, this is sufficient to pull the box file, which is essentially the VM, from the HashiCorp servers right down to your local machine and add it to your Vagrant box list. The Vagrant box list you can see yourself if you were to go to the command line and type Vagrant box list, which I'll do here to show mine. I have quite a few, and actually several with the same name, Ubuntu Trusty 64, but Vagrant knows to use the one with the latest version. You can specify the version if you like, if you want to override this behavior, but we're just going to use the latest one. So this is kind of like a store of all of the box files that I've ever used, or used recently anyway. And it keeps these around so that I don't have to download the box file every time I type Vagrant up. The config VM network tells requests coming in at port 8000 to be forwarded to my VM at port 5001. Which is nice because I can use my favorite browser to test my application while my code executes inside the virtual machine. And my code will be provided inside the virtual machine, as we will see in that /Vagrant folder that we saw in the environment configuration. Here I'm telling Vagrant that I'm using VirtualBox as my provider. VirtualBox works with many providers, VMware Player, and even some remote instances such as vCenter, if you like. The provision block tells Vagrant to use Chef 0, and we're going to provide it with the environment name development, which directly references the development environment file that we created earlier, which sets the base folder attribute to Vagrant, which we used in our recipe. So every time this recipe runs, it's going to basically use the base folder chef attribute based on whatever environment we tell it to use. So for Vagrant, it will be development. And then to the VM node that we'll be managing, we add two roles, API and web. So the nice thing about splitting up the configuration files the way we did is that we make the roles and the nodes independent of each other. For assignment, we're basically defining our infrastructure here as we go. The last thing we'll do before we add this is create our requirements.txt file and then Vagrant up. The first thing that Vagrant is going to do is it's going to import the base box that we've selected from our box list. Basically make a copy of it. It checks the version of our box for us, sets the name, sets up some networking parameters, port forwarding. These are the kinds of things that you would have to do if you were to go into VirtualBox or your virtualization client of choice and have to set up manually. Vagrant is doing this for us. It uses a key, a public-private key, so that we can SSH into the box. This output here is the upgrade. It's actually a downgrade of guest editions. It's matching the version of guest editions on the box to what we have available to us in VirtualBox. So the box actually shipped with 4.3.36. So we're going down to 4.3.30. So it finished that. If you didn't have the VB Guest plugin installed, you wouldn't see that output. The /Vagrant folder is being shared by default. Vagrant gives us gives that to us out of the box, puts our application code right into the VM, and then it shares all the chef folders for the configuration into the VM. Installs chef, assembles the run list, which is comprised of the 2 recipes that we selected, API and web, based on the roles that we added to the node in the Vagrant file. The 2 recipes, if you remember, were very similar, identical in fact. Chef is smart enough to be able to consolidate the requirements for both of those and only install what's needed. Now, a lot of that was one-time run. If you were to run Vagrant provision again, it would re-execute the provision blocks in the Vagrant VM, but the VM is already imported, it's already running, Chef is already installed, so all it needs to do is run the run list again, so it's fairly quick. We can type Vagrant SSH to be put inside to the VM at a shell prompt. /Vagrant holds our application code. This is a share from our host machine, so that any changes that we were to make on our host machine in our IDE would be reflected here. And so we can execute the scripts running in Ubuntu, where we expect to be running in a remote environment based on our choice. We see that it actually doesn't run yet, even though we ran both scripts. Why doesn't it run? Because Flask by default listens not on all interfaces, and we have to tell it to listen on all interfaces because we're actually running on a different machine now. We're running inside the VM, and in order to be able to hit that interface, we actually have to explicitly listen on all interfaces. So this is the front end for the web application. We can see we're at localhost 8000, which is being forwarded to our guest at 5001, and you can see in our front end file when we had that open that it was listening on 5001. This is the node configuration that Vagrant has generated for us. You don't want to check this into source control. This is every developer would have their own copy of this, which is what the gitignore file in our example prevents that from being checked in. Now on to the second section of our demonstration. We're going to be working from version 0.20 to 0.30, which is going to involve adding a test environment and on top of our development environment that we created in the first section, and also adding a deployment script that will be written in Fabric. This is going to allow us to deploy our application to a test server that we have configured for ourselves in Microsoft Azure that we already have set up. The one pre-configuration step that we did was installing a public key so that we may remote to that machine without using a password, which is going to allow us to run our deployment script much more efficiently. So if you want to switch, check out V020, and this will be the starting point if you did not complete step 1. If you did, you can continue from where you left off. So the first thing we'll do is add our test environment script, which you can see is almost identical to the development environment script with the exception that the base folder attribute has a different value. That means that we're going to be deploying our application code to a different place inside the virtual machine. The second thing we'll do is add a node that represents our staging server, to which we'll add the 2 roles, web and API. You can see it's the same thing that we did in our Vagrant file, adding our API and web roles to the development node. So right now our test and development environments are almost identical, basically identical. We're adding a Shift configuration file called client.rb just to set some logging parameters. This file is used by Chef. We will explicitly reference it in our deployment script. But in the Vagrant file, when Chef client executes, it just looked for that file in its default location, and it was blank for development. So this is our Fabric deployment script. This is just Python. Write it however you like. This could just be a shell script. It does not need to use Fabric. This is just what we chose for implementation. env.host, you can see in the setup hosts function, sets a parameter that Fabric knows about. So it will cycle through an array of any host that we provided and run the deployment script. You can see the runs once decorator, which tells these just to do one thing. So despite how many hosts we might have in the array, it'll only do this once. The package function basically tars up the application code. We push the code to our server. We install Chef if it needs to be installed. We could also specify a version there if we like. And the actual deployment is just in a single line that runs our user bin Chef client binary in local mode, which is Chef 0, references the client RB file we created, and passes in an environment flag that will pass it on the command line. And since we're deploying to test, that is the name that we will use when we execute this on the command line, as opposed to development. So it's the same thing. We're saying instead of development, we're going to pass in test. And we're going to use tpalco, as I said, that's my username. We have a public key installed on the server so that we can access it without a password. So let's get onto the box, just to show there's no magic going on here. This is our staging server. And varchef doesn't exist. There is no code on the server. It's not running anything. We go to the endpoint. Nothing's there. Certainly not running our application. So to execute our Fabric script, we're going to run fab and a list of all the functions that we found in our deployment script. Set up hosts. We'll pass in test, package. Those will run once each. And deploy test will run for as many hosts as we've defined, which is just one. It's installing Chef as we asked it to if it was not already installed, which just takes a minute. And when Chef is installed, it will execute the client script that we asked it to install. And it ran our recipes, and it was that quick. It did the exact same thing it did there as it did on our local VM. We're on the box, so we'll start up our services the same way we did in part 1. With screen, run one, and then run the other, and we have our application front end. You'll notice the images aren't serving. I believe IMDb throttles how it serves up those images, so sometimes they work, sometimes they don't. But this is it, and we're full one-to-one parity with development. Now we're going to move on to the last section. This is going to be working from version 0.40 to 0.50. We're going to briefly cover the changes that we made in version 0.30 transition to version 0.40, which involved making some external configuration files, setting up upstart services to run our applications rather than having to go in and run them manually, which is going to help us show some of the templating features that Chef gives us, and especially in a multi-environment setup. So make sure that you are you're starting from version 0.40. If you've been following along, you will need to skip to this version to be able to see the same code that we're working with. But again, feel free to experiment, play with the application code, and see how it works with Chef and Vagrant. This is definitely your thing to experiment with. So one of the biggest changes that we made from 0.30 to 0.40 is adding these template files. You can see they're in the cookbooks folder because they're used by the recipes. So we have recipe code that will deploy these, and you can see that we're using chef attributes inside the template files. And again, from earlier sections of the demo, you'll remember that chef attributes are environment dependent in their value. So depending on what environment we're deploying these templates to, these values will be different, which is a fantastic advantage when you have a multi-environment system. We also split the requirements txt into each application. We can see that we separated into a web app folder, the front end py, and we're reading from a configuration file for our values rather than having them hard-coded inside the application. This enables us to put the values for these, separate them into a configuration file that we template with chef, and that we provide those values, like I said, per environment with our environment file. Our API is again in a services folder. It does the same thing. It loads the application environment specific values from a configuration file which we template using environment variables. Each application has their own configuration file that's deployed from this templates folder. The templates files end in .erb because they initially start out as Ruby templates, which we pass these chef attributes into. And the chef attributes are pulled directly from, you see we have services username, service password, and they're all located directly in the environment file. So we have one place to store all of the values for a particular environment, which makes this template file environment agnostic. And we do that for all of the different, you can see that the difference between development and test is minimal. We turn debug off, is probably the biggest decision that we make between one environment and the other. This service delay sec is an interesting little quirk about running in Vagrant. If you're running an upstart service, oftentimes running on run level 2, 3, 4, 5, the upstart service will try to kick off before Vagrant has had a chance to configure VirtualBox to set the shared folders up. So it will try running the service before the files actually exist. So that's a little bit of a hack that you may have to put in for Vagrant to be happy. We turn that to 0 for the test environment. Again, the API and the front-end debug flags are turned on in test and off. I'm sorry, on in development and off in test. So the install requirements now has to point to a different folder because we have separated our requirements txt file. This is the template chef resource. It takes the source file, it knows where to find it in templates default folder, and it places it into the VM wherever we specify in the template name. So here we're utilizing again our base folder attribute. And the same thing goes for the upstart configuration. And then we have a bash resource that we specify code to just kick up the upstart service as part of the deployment. So this allows us to have the services up and running at the time of provision rather than needing to go into the VM and kick up the services manually. So that's the bulk of the change that we made moving into version 0.4.0. So let's get started. We'll create our production environment file, which is really very similar to the test and development environment. We're going to need to duplicate all of the chef default attributes, but we'll set specific values here, such as the service password, which means we may want to be different in production than we do in development and test. And we're able to do this because actually on the startup of the Flask API, we create this account. So right when the application starts up, it creates that account dynamically. So this allows us to set this password in the provision script if we want to. Just another example of how we can we can make the different environments distinct. This service name, service username, and service password are used in several places. It's also used on the front end, but we define it only in one place, and that is in the environment file, once for each environment. The API host is also different because we're not looking at localhost anymore. For our Flask API, we're looking at a different server. In the production environment that we're using, we have 2 separate VMs set up. So we're going to show how we can use 2 different nodes with the same role recipe configuration simply by assigning different roles to different nodes. This is the separation that is so valuable in our configuration. We're essentially defining our infrastructure in our configuration script. So we can see one node has the API role and one node has the web role. DB01 will carry API and Web01 will carry web. And this is where we get the value for the API host. The last thing we'll do before we can do our production deployment is actually add our production hosts to the fab file. So all we need to do is add another key to our hosts. We can see that when we call setup hosts, that it's going to pull the correct hosts from the environment that we pass in. So let's kick off our production deployment. We're going to run the same Fabric script we did before. Set up hosts with our new production environment, package it up, and deploy using the production environment name, deploying to the 2 production hosts that we defined. It's going to install Chef on each one, as this is our first deployment to these servers. It'll kick off the Chef script, run the single recipe that we defined for the API node, and then do the same thing for the web node. Pushing the code to it, installing Chef, running the single recipe that we defined for the web role, which all happens pretty quick. And where once we had no app, now in production, we have our front end. Thank you for watching.